So students, welcome again. Let us take another example. This is a very simple case. A production house finds that production of cost is directly attributed to each pen is rupees 25 and the fixed cost is rupees 25,000. If each pen can be sold for rupees 100, then determine the cost function, the revenue function, and the third thing is the break even point. I haven't yet discussed you break even point. Okay, I will discuss here. Break even point is not a new thing. So what is given here? A production house finds that the production of cost is directly attributed to each pen is rupees 75. So the cost of a pen is rupees 75. Right? See how we can construct the cost function. This you can also learn from this example. One pen cost rupees 75, right? Fixed cost is this. You know about the fixed cost. Fixed cost means the cost which remains fixed. It has nothing to do with the production, right? This is the fixed cost. If each pen can be sold at the rate of rupees 100, then determine. So the cost of a single pen is rupees 75. For example, the firm is producing X number of pens. Then the cost of production for X pens will be what? That is equals to 75x. Is it or not? Because the cost of one pen is rupees 75. The cost of 3 pens will be what? 3 into 75. The cost of 10 pens will be what? 10 into 75. Suppose the firm is producing X number of pens. So the cost of X pens will be what? 75 into X. Clear? I think it is clear. So let the production of house produces X number of pens, right? The same thing what I have told you. The fixed cost is given to us and the variable cost is considered as 75x because the cost for a single pen is rupees 75. So if X number of pens are being manufactured by the firm, so the total variable cost incurred for manufacturing of X number of pens will be 75x. And we know that what is the total cost function? Total cost function is the sum of the variable cost plus fixed cost. So the total cost function Cx is equals to 75x, the variable cost, plus 25,000 as the fixed cost. So case 1 is done. We have to determine the cost function. Case 2, the revenue function. You know what is the revenue? Revenue is equals to P into X. P means the price per unit of a commodity. X number of commodities sold. Right? So the revenue function Rx price per pen. Sorry, this is pen. Number of pen sold. The price of a pen is given as 100 rupees, that is Px, right? P is given as 100, so the revenue function will be given as 100x. So this is your cost function, this is your revenue function, right? This example also shows that how you can determine or how you can write down the total cost function as well as total revenue function from the given data. The third case is break-even point. You all know that the break-even point is a point at which the firm runs without no loss, no profit. No loss, no profit means what? Whatever expenses incurred, you are receiving the same amount of revenue generated. That is, the break-even point is a point at which the cost function is always equals to revenue function. So cost function you have 75x plus 25,000. This should be equals to 100x. Simplify this. So there are 1,000 pens required at which the firm will run without no loss, no profit situation. Right? Take one more example very quickly. The fixed cost required for manufacturing a new product is rupees 35,000. Look at this carefully. This is your fixed cost. Fixed cost is equals to 35,000. And the variable cost per unit is rupees 500. per unit means the cost for 1 unit is rupees 500. If the demand function is given like this, find the break-even values. Break-even values means the point at which the total cost and total revenue both are equal. So what is our objective? We will determine the total cost function in this question first from the data given, and then we will determine the total revenue function. According to the condition at a break-even point, the total cost function should be equals to the total revenue function. So see, 35,000 is the fixed cost. Rupees 500 is the price of a single product, that is one commodity. So if X number of commodities are being produced or manufactured by the firm, then the variable cost will be 500 into X. So total cost TC is what? 500X variable cost plus 35,000 and fixed cost. See this, let X number of new products are manufactured, the fixed cost is given this and the variable cost will become 500X because the cost of a single product is rupees 500, right? So the total cost function is obtained by this, that is 500X plus 35,000. Now, this is our total cost function. Now, find out the revenue function. We know the revenue function is equals to P into X, price per unit of a commodity and number of commodities sold. P here is given as like this, 500,000 minus 100. Multiply this with X, you will get 5,000X minus 100X square. So this is your revenue function. And we know for a break-even point, the total cost function should be equals to the total revenue function. Substitute 500X minus 35,000 must be equals to 5,000X minus 100X square. Simplify this equation, you will get this as an equation, and you know this is a quadratic equation. Naturally, it will have two factors and its factors are coming out to be 35 and 10. So if 35 units or 10 units of a commodity are being produced under this condition, then the firm will run without no profit, no loss, right? Oh, this is also an example. This is a very somehow different case, but we will use the same technique. I will not explain the solution of this question. So I will leave this question for you as an exercise. Try to find out its solution yourself. See, let me explain a little. If the demand law of a given firm is this, express marginal revenue as a function of X. Look at this carefully. This is given as the demand law, as X is equals to A e raised to the power minus BP. What is the demand law? We know that in demand law, P is a function of X. What is given here? X is a function of P. It has been reverted. So what we will do, first we will find out P as a function of X. So from this equation, we will find out the value of a P that will represent as a demand function. See, the demand function is given by this. Taking log both sides, what you will get here? You will get here, see, log X is equals to, let us see some calculations. Log X is equals to, what you will get here? Log A minus BP, is it? Because log E is 1, right? Now, find the value of P from here. The value of P from here will be given by 1 upon B log A minus log X, right? This is the value of P. Now, this is your demand function. And if demand function is there, you know what is the value of revenue? Revenue is given by P into X. So P is this, multiply this quantity by X, you will get as the revenue function. So TR, total revenue, is equals to PX, 1 upon B into X. This is your total revenue function, right? So we have calculated the revenue function. What is the next? Determine the level of output and price at which the revenue is maximum. So naturally, now you can proceed yourself, right? Total revenue function is with you. What you have to do, find out the value of X for which this total revenue is maximum. So total revenue is there, find out its first derivative, right? After getting the first derivative, put it equals to 0. You will get certain stationary points. And then find out the second derivative, put the stationary points in the second derivative. If second derivative is coming out to be negative, then that stationary point will be considered as a point of maximum. So this is your total revenue. This is what we have differentiated it to find out the marginal revenue. It is coming out to be 1 upon B log A minus B, the formula we have used here. You will get here log A upon X minus 1. So for maximum revenue, dr over dx must be equals to 0. So log A upon X minus B is equals to 0. This means log A upon X is equals to 1. So A upon X is equals to E. X is coming out to be A upon E. So this A upon E is known as stationary point. Now to check this maximizes total revenue function or not, find out the second derivative. The second derivative is coming out to be minus B upon X. So put X is equals to A upon E. The second derivative is still negative. And naturally, if the second derivative is coming out to be negative, it means that the function has maxima. So if X is equals to 1 upon X is equals to A upon E is the quantity sold, then the revenue will be maximum. And the price, what you have to determine, also find the max total revenue price. Okay, price we have to also calculate. So naturally, price means P. X is equals to A upon E. Put the value of X in our demand function. 1 upon B is the value of P. Hence, the maximum value of the total revenue is A upon E. We can determine the total revenue also. The total revenue generated by the firm is coming out to be A upon BE. So I think this is all about the revenue function. So this is also an example you can do yourself. A monopolist demand curve is P is equals to 200 minus 5x. Find the marginal revenue function. What is the relationship between slope of the average and marginal revenue curves? I have told you about the slopes. If you want to calculate the slope of any function, find out its first derivative. It will give you the slope. At what price the marginal revenue is 0. Right? Take the simple case, it's very simple. A monopolist demand function is this. P is equals to this. Find the marginal revenue function. So naturally, to find the marginal revenue function, first find out the total revenue function. We know that the revenue function is given by R is equals to Px. P is given as 200 minus 5x. So multiply 200 minus 5x by x, you will get 200x minus 5x square. This is our total revenue function. Now to find out the marginal revenue function, we will find out its first derivative. The first derivative of this is what? 200 minus 10x. This is your marginal revenue function. To find out the average revenue means divide this total revenue by x. You will get 200 minus 5x as average revenue. What you have to calculate, what is the relationship between the slopes of the average and marginal revenue? See, 200 minus 10x, right? This is your marginal revenue. Be careful. This is your marginal revenue and this is your average revenue. So to calculate the slope of the marginal revenue, find out its first derivative again. So derivative of 200 minus 10x, 200 is a constant and derivative of minus 10x will be 10. And to find out the slope of the average revenue, find out the derivative of 200 minus 5x. So derivative of 200 is 0 and derivative of minus 5x is 5. So its slope of the marginal revenue is 10 and slope of the average revenue is 5. So naturally from this relation we can see that the slope of the marginal revenue is just 2 times to the slope of the average revenue function. At what price the marginal revenue is 0? So what is the value of the marginal revenue if P is equals to 0? So see, 200 minus 10x our marginal revenue? The marginal revenue is 200 minus 10x is equals to 0. So 200 minus 10x is equals to 0. This means x is equals to 20. So if x is equals to 20, put the value of x in our demand function. The price is coming out to be 100 rupees. Hence, the marginal revenue is 0 when the price is rupees 100. So you can calculate almost everything from the data given. So after having the discussion of our total cost function, then total revenue function, so naturally the last stage is what? How we can calculate the profit function. I have told you in the very beginning of this session, if the money is going out of the firm, it is known as the cost. If the money is coming inside the firm, it is known as the revenue. And the difference of the revenue minus cost is known as the profit. So we will calculate the profit function by calculating the cost function first. Either we will calculate the cost function from the data given, or cost function will be given to us. Second thing, similar way, either we will calculate the total revenue by using the given data, or the total revenue will be given to us. So anyway, we need to have the difference of the revenue minus cost. That will give you the profit, and in this portion the profit function is always maximized. So use the same process as we did in case of the revenue function. You know how a function is being maximized. So profit function will be maximized as follows. Let's have a look. Find out the profit function first by taking the difference of revenue minus cost. Clear? Find out the profit function first. It's a very simple process. Don't be scared. Find out the profit function first by taking the difference of revenue minus cost. Right? Profit function is there, and you know how to maximize a function. So if profit function is with you, find out its first derivative and equate it to 0. It will be treated as an equation. Solve this equation, you will get certain stationary points, and these stationary points will give you the point of maximum. So which point among these stationary points will give you the maxima? For that we will find out the second derivative of the profit function and put the value of the stationary point in the second derivative. If second derivative is coming out to be negative, then that stationary point is considered as the point of maxima, right? So we will use the same process. So look at here. The profit function is a functional relationship between profit earned from the production of a sale of a commodity and the number of units produced as well as sold. The profit is evaluated as the difference of the total revenue minus total cost of production and sale of the commodity. The profit is always calculated by taking the difference of total revenue minus total cost. So this is the simple formula to calculate the profit, R minus C. R, as I have told you, either it would be given in the question. If not, you can calculate the formula of R is what? X into P, or P into X. C, the cost function, will be either given or you can calculate as we did in the exercise earlier, right? So by having these two terms, only then we can talk about profit, right? Once the profit is there, what we will do? See, dP over dx, its first derivative, it should be equals to 0 for getting this stationary point. So if P is equals to R minus C, so C, dP over dx will be what? dr over dx minus dc over dx. So if dP over dx is 0, it means dr over dx is equals to dc over dx. And what is dr over dx? dr over dx is the marginal revenue and dc over dx is the marginal cost, right? So the first order condition for profit maximization is also sometimes marginal revenue should be equals to marginal cost. And after using the first order condition, this will give you some stationary values. The second condition is as usual, the second derivative should be negative for any stationary value, only then the profit will be maximum. Actually, profit is considered as a very important aspect in business. Everything is being done for the profit. So a number of formulas are developed to make the profit maximum. See, this is also one of the conditions. Whenever the marginal revenue is equals to marginal cost, this is the first order condition for profit maximization. We will study some more conditions further also. Likewise, revenue, the profit can also be governed under two basic conditions. The first condition is what? Profit maximization under perfect competition, and two is the profit maximization under monopoly. Under perfect competition, the price of commodity is considered to be constant, as we have already discussed in the case of revenue, and the company can sell as much as it wishes to sell at this constant price. So first order condition for profit maximization is marginal cost is equals to P. This keep in your mind. Marginal cost is equals to P, and second order condition is what? D square C over dx square must be positive under perfect competition. And see what happens under monopoly. Under monopoly, what happens? The monopolist wishes to control the quantity produced, and hence the price per unit determined from the demand function so that the profit will be as large as possible. I have told you, under monopoly, what is the objective of the producer? He always maximizes his profit up to its maximum extent. So in this case, the prices are being determined by the producer itself. The first order condition under monopoly, the marginal revenue must be equals to marginal cost, and the second order condition is what? Derivative of the marginal revenue should be less than derivative of the marginal cost. So among these two conditions, either this or this, we can use any one of these two as per situation of the question, whether the question is being carried forward under perfect competition or it is being working under monopolic situation, right? So let us take some examples. Example 1, find the profit maximizing output given by the following revenue and cost functions. So look at in the first example, I have told you in the beginning when we started the profit function, the revenue function or the cost function will be given to you in the question. If not, then you can calculate it. Here, fortunately, we have given the revenue function this and cost function both. So naturally, the process is very simple. If the revenue function is given and the cost function is given, you can very easily find out the profit function. So the profit function Px is given by Rx minus Cx. This is your Rx, this is your Cx. Take the difference of these two. So this is Rx, this is Cx, and the difference of these two is coming out to be this, right? You can check it. This is a simple subtraction, right? So this is your profit function. So profit function is coming out to be what? Px is minus x power 3 plus 57x square minus 315x minus 2000. This is our profit function, right? This is a general function and we have to maximize it. So we know that for the first order condition is what? dp over dx is equals to 0, right? Find out its derivative. What will be its derivative? Minus 3x square plus 57 into 2 is what? 57 into 2, 4x minus 315. This is equals to 0. 2000 is a constant, so its derivative will be 0. So divide by 3. What you will get? X square minus 38x plus 105. This is your equation, right? So this is an equation of order 2 or degree 2. So it will have two roots or two factors. So we will find out its solution. We cannot find out its factor. So we will use the formula, quadratic formula. That is, x is equals to minus b plus minus root b square minus 4ac divided by 2a. This is a formula which you all have studied at your 9th standard. We will use this formula. You know what is b? B is here minus 38, a here is 1, and c is 105. So substitute these values here. 38 plus minus 38 is square, that is b square, minus 4 will remain as it is. I have told you a is 1, c is 105 upon 2. Simplify this, you are getting the value of x is 35 or 3, right? These two values we are getting. So x may be 35 or 3. 35 and 3 are known as stationary points or stationary values, right? So second order condition for maximum profit is d square p over dx square is minus 6x plus 114. This is your second derivative. Now put x is equals to 3. At x is equals to 3, second derivative is coming out to be 96, that is greater than 0. And at x is equals to 35, the second derivative is coming out to be 96, that is negative. So this is the point of maxima, means x is equals to 35, the profit will be maximum. That is, if 35 units of a commodity are being produced or demanded in the market, then the profit will be maximum, right? Let us take another example. Say total cost function for manufacturing a product is given by this. See, this is also a total cost function here given, where x is the number of units produced. The price at which each unit can be sold is given by this. So this is the price. Be careful. Determine the production level x at which the profit is maximum. What is the price per unit and the total profit at this level of production, right? So see here, the total cost function is given to S, right? What we need to calculate further, R. R is equals to, that is revenue, P into X, right? The demand function is given as 200 minus X upon 400 multiplied by X. So the revenue will be what? 200x minus x square upon 400, right? This is our revenue. So this is Px is equals to Rx minus Cx. Rx is this is Cx, the difference of these two is this. So Px is coming out to be what? 100x minus x square by 80 minus 40. This is our original profit function. We have to maximize it. For maxima, dp over dx should be 0. We know that. What is the dp over dx? dp over dx will be derivative of 100x is what? Derivative of 100x is, you will get here 100 and minus x upon 40. This is equals to 0. From here we are getting x as 4000, right? And the output here is coming out to be 4000. So see whether at this 4000 the profit is maximum or not. We will find out the second derivative, that is d square p over dx square, right? So d square p over dx square is coming out to be minus 1 upon 40. Naturally, if dp over dx here is 100 minus x upon 40, then its second derivative is what? D square over p over dx square, derivative of 100 is 0, minus 1 upon 40, because derivative of x is 1. And this is always negative. So at x is equals to 4000, the second derivative is coming out to be negative. So at x is equals to 4000 of output, the profit of the firm will be maximum. What you want to calculate further? What is the price per unit and total profit of this level of production? The profit is maximum when x is equals to 4000 units are being produced. Okay, this we have already calculated or proved. Equilibrium price, and we want to determine the price. You know the demand function is Px is equals to 200 minus x upon 400. If x is 4000, put x is equals to 4000 in our demand function. If we will put x is equals to 4000 in our demand function, we will get the price of the commodity. So the price is here, see, 200 minus X, here is 4,000 divided by 400, you will get 100, 200 minus this, you will get here 200 minus 10, that is rupees 190, right? And what is the third thing? That is the total profit. So profit function is what? This is our profit function, this. See, this is our profit function. So total profit means what? At X is, put X is equals to 4,000 here in this function, profit function, right? Be careful. This is your profit function. Put X is equals to 4,000 in this function and then simplify it. 100 into 4,000 minus 4,000 square upon 80 minus 40. Simplify all these, you will get rupees 2,000,040 as a profit of the firm. So, okay students, I think this is more than sufficient. I should stop it here. Thank you very much for your patience learning.